Hello and welcome to a new CNCM video, and today we are covering the 2018 AP Calculus AB free response question number 5. And we've decided to go cover some AP exam FRQs since the AP exam format has changed and now it's all free response questions for this year. So let's go ahead and do this free response question. So the function is f of x is equal to e to the x cosine of x. I had this PowerPoint with the free response question split by parts, so we just need to note that. Alright, so our first part of the FRQ is find the average rate of change of f on the interval 0 is less than or equal to x is less than or equal to pi. So let me switch over to this other screen. Alright, so we're trying to find the average rate of change of f of x is equal to e to the x cosine of x, and that's on the interval 0 is less than or equal to x is less than or equal to pi. Remember that the formula for the average rate of change of a function f is simply f of b minus f of a over b minus a on the interval a is less than or equal to x is less than or equal to b. So all we have to evaluate here is f of pi minus f of 0 over pi minus 0. So let's evaluate that. Alright, so f of pi will give you e to the pi times cosine pi. You know that cosine pi is -1, so that will actually become negative e to the pi power. And for f of 0, we know that e to the 0 is equal to 1, and cosine of 0 is equal to 1, so that's 1 times 1, so we just subtract 1 here. And pi minus 0 is pi. And that, since there's no units given for the problem, we can just end with this. That is your average rate of change. Excellent. Okay, let's move on. So our next part of the FRQ is part B. What is the slope of the line tangent to the graph of f at x is equal to 3 pi over 2? Well, remember that if you want to find the slope of the tangent line at a point on the graph, all I have to do is evaluate it at the derivative. So what we're trying to find is f prime of 3 pi over 2. Alright, so that's great. First, we have to find the derivative, obviously. So we remember our original function is f of x is equal to e to the x cosine of x. Well, to take the derivative, remember we have to use the product rule. So the product rule tells us that the derivative is the first function times the derivative of the second function plus the derivative of the first function times the second function. Or if you want to list it out, let's say like the first function was g of x and the second function was h of x. The product rule tells us that we're trying to evaluate that's h of x. That's what we're trying to evaluate. So let's go ahead and do that. So f prime of x is equal to, so the function e to the x stays the same. The derivative of cosine of x is negative sine of x, so we'll keep that in mind. So we'll write that down. The derivative of e to the x is e to the x, so we can keep that. And we just have cosine of x, and we multiply that. So I'm going to go ahead and factor out an e to the x here just to make things simpler for us as we move along. And I'm going to make, since that's cosine of x and that's negative sine of x, this is the same thing as cosine x minus sine x. Sorry for all the specs on the screen. I can actually go ahead and erase those real quick. Alright. So now we just have to find f prime of 3 pi over 2. Well, that should be an easy evaluation since we have the function here. So we know that the first part is e to the 3 pi over 2. And now we have to evaluate cosine 3 pi over 2 and sine 3 pi over 2 to get our final answer. Well, cosine of 3 pi over 2, let me just write the e to the 3 pi over 2 here. Cosine of 3 pi over 2 is going to be 0. Since if you look at the unit circle, 3 pi over 2 lies right there. And that has a x-coordinate of 0. And that also tells us that our sine value is negative 1. So that is going to be 0 minus negative 1, which is just 1. So indeed, our slope at the tangent line is e to the 3 pi over 2. Try to circle that right there. And so that is our answer to part B of the FRQ. Moving on. So we have part C of the FRQ, and that is to find the absolute minimum value of f on the interval 0 is less than or equal to x is less than or equal to 2 pi. So remember, when you're trying to find the absolute minimum or maximum value of the function, you have to consider you're supposed to consider the relative extrema, so the relative minimum and maximum values. And you also have to consider the endpoints. So let's go ahead and do that. So, well, you remember that our function is f of x is equal to e to the x cosine of x. And our derivative is f prime of x is equal to e to the x cosine x minus sine of x. Okay. Well, to find our relative extrema, we just have to set the derivative equal to 0. So this is going to give us the following expression. That's interesting. So to find the relative extrema, we can split this. So if any one of these is equal to 0, one of these parts of the product, then we can find x values based off that. Since this is a factor, this tells us that e to the x equals 0. Does that net any solutions? Well, e to the x is always a positive function. It never hits the x-axis, so this doesn't return any x values. Our next part of the expression is cosine x minus sine x is equal to 0. Well, this tells us that cosine x is equal to sine of x. Well, what values is that? What values is that equal to for the range 0 is less than or equal to, well, the domain 0 is less than or equal to x is less than or equal to 2 pi. Well, if you look at our unit circle here, well, we know that at pi over 4, that both the values are equal. And since they're both positive, that's true there. And we also know this occurs here at 5 pi over 4. Both values are negative and equal. So that's going to give us the x values, pi over 4 and 5 pi over 4. So that's good. So we have a relative extrema. That is x is equal to pi over 4 and 5 pi over 4. Nice. So now we also have to consider the endpoints. So that's going to give us x is equal to 0 and x is equal to 2 pi. All right, so what do we do with these values? Well, we're trying to find, as you remember, we're trying to find the absolute minimum value of f. And so Now we're considering those endpoints, we just have to plot them. Well, we have to find their value of f of x, and that will tell us some things. So remember, our points are x is equal to 0, x is equal to 2 pi, x is equal to pi over 4, and x is equal to 5 pi over 4. Since this is where all our relative extrema and our endpoints are, if we can find the lowest value of f of x on these values, then that will be our absolute minimum value. So let's go ahead and look at this. So let's make a chart here. So we have x value and f of x. So remember that that's equal to e to the x cosine of x. All right. So let's evaluate this at 0. That's going to give us e to the 0 cosine 0, which is, we evaluated this earlier at part A. It's just 1 times 1 equals 1. So we can put 1 there. All right. Next value is 2 pi. Well, this gives us e to the 2 pi times cosine 2 pi. Well, we know that cosine 2 pi is equal to 1, so this is equal to e to the 2 pi. Okay. Our next value is pi over 4. And so we know this is going to be e to the pi over 4, and we have cosine pi over 4. Recall that cosine pi over 4 is equal to the square root of 2 over 2. So this gives us e to the pi over 4 square roots of 2 over 2. All right. I had to rewrite that, I guess. Wonderful. Now, if you go on here, we have one more value to test. That's 5 pi over 4. And if we evaluate that, that's e to the 5 pi over 4. And multiplied by cosine of 5 pi over 4. Well, if you find the value of cosine 5 pi over 4, it is negative square roots of 2 over 2. So this is actually equal to negative e to the 5 pi. Actually, let me just write that here. Negative e to the 5 pi over 4 square roots of 2 over 2. So looking at these, what's the smallest value? This is the only negative value out of the whole list. So this is our answer. So I'm going to show you how to write it to get points. So let me just clear this right here. The way to get points for this value is you just simply write the absolute minimum value of f on the interval 0 is less than or equal to x is less than or equal to 2 pi is negative e to the 5 pi over 4 square roots of 2 over 2. And that's how you would write this answer in a free response just at the end so you can get that point. All right, so we're done with that part. Let's go on to the final part of our FRQ, and that's an interesting one. So it says, let g be a differentiable function such that g of pi over 2 is equal to 0. The graph of g prime, the derivative of g is shown below. Find the value of limit of x to the, as x approaches pi over 2 of f of x over g of x, or state that it does not exist, and justify your answer. Well, let's look at this. So, first of all, what can we evaluate this limit directly? So, let's look at that. So, if we go ahead and try to do that, x approaches pi over 2 of f of x over g of x. Well, this is equal to f of pi over 2 over g of pi over 2. Well, it's equal to the limits of those. Well, let me rephrase this for you. So the thing is that since f is a continuous function, e to the f of x is equal to e to the x times cosine of x. Since that's a continuous function, we can say this. However, for g of pi over 2, is it continuous? Well, it says it's differentiable in the problem, so thus it is continuous. So if we can say that that value really does equate, we have to say that since g is differentiable, it is continuous. All right. So that tells us that we can just straight plug in g of pi over 2 into g of pi over 2 to find the value of the limit. So f of pi over 2, if you recall, e to the x times cosine of x. Cosine of pi over 2 is 0, so that's actually going to equate to 0 at the top. And g of pi over 2, since we say that it's continuous, we can go ahead and say that the limit of g of x as x approaches pi over 2 is g of pi over 2. This gives us that it's equal to 0. Well, this limit doesn't really have, well, it's 0 divided by 0. However, that is an indeterminate form, so we can actually use L'Hopital's rule. So first, we obviously have to justify our usage of L'Hopital's rule. So let's do that now. Before I do that, I want to state that we need to know the values of f prime of pi over 2 and g prime of pi over 2. Since I'm not going to come back to the screen, I'm just going to show you that the value of g prime of pi over 2 is 2. So we'll keep that in mind, according to this graph. All right. So we have the limit as x approaches pi over 2 of f of x over g of x. Well, to justify our usage of L'Hopital's rule, we're going to have to show that both the top and bottom limits are equal to 0. So that's going to give us the limit as x approaches pi over 2 of f of x. We know that's equal to f of pi over 2, as said earlier, and that is equal to 0. And we can also go ahead and do the bottom. We have to do both to get the credit here. X approaches pi over 2 g of x, and that's equal to g of pi over 2, which was stated to be 0. Since both are 0, we know that therefore L'Hopital's rule applies. Perfect. All right, so I'm going to clear the screen now, since now that we have justified the usage of L'Hopital's rule. I'm going to go ahead now, and since we know that it works, we'll go ahead and apply it. So we have this limit that we're trying to evaluate. And now we know that this is equal to the limit as x approaches pi over 2 of f prime of x over g prime of x. And since both functions are continuous, we know this is equal to f prime of pi over 2 over g prime of pi over 2. So we do have to evaluate those. I told you from the graph earlier that g prime of pi over 2 is equal to 2. So we're good on that. Now we just have to evaluate f prime of pi over 2. So if you recall from part B, the derivative of f was e to the x times cosine of x minus sine of x. All right. So now, let's just plug it in. So f of pi over 2 is equal to e to the pi over 2 power cosine pi over 2 minus sine pi over 2. We know that cosine pi over 2 is 0, sine pi over 2 is 1. So let's go on. So that's going to give us e to the pi over times 0 minus 1. It's going to give us negative e to the pi over 2. So our limit is equal to f prime of pi over 2, which is negative e to the pi over 2 power. Let me just go ahead and do that. And it's divided by the limit of g prime of pi over 2, which is 2. Or just g prime of pi over 2, which is 2. So that is your answer right there. And we are done with this FRQ. Thank you so much for watching this video. I do hope that we can make some more of these videos in the future. So if you are interested in joining our Central NC Math Group Discord, you can join through the link in the description below. I will provide that for you. If you need any help, we'll be able to provide that for you in our channels. Just mention any one of us. We'll be able to help you with any calculus questions you need for the AP exam. Thank you so much for watching. I will see you later. Good night.